Welcome to The Explainer. Today, we're jumping right into a problem that's a huge headache for developers and, frankly, keeps security teams up at night. How do you manage one single, secure identity for a user who needs to get into a bunch of different cloud platforms? It's the multi-cloud identity puzzle, and today, we're going to piece it together.
All right, so let's get a really clear picture of the problem we're talking about. Just imagine you've got one user, and that person needs access to stuff in AWS and also in Azure, and Google Cloud too. Right off the bat, you can see how things get complicated and fast.
And this is the million-dollar question, isn't it? As an organization, you can't just go and create 3 different accounts for that one person. I mean, that would be a total security nightmare, not to mention an operational mess. You need one single unified identity, one login that just works everywhere. The question is, how do you pull that off?
And look, this isn't just some abstract theoretical issue. The pain is very, very real. Just check out this comment from a developer on Reddit. You can feel the frustration. This complexity doesn't just affect logins. It ripples through everything, making something like your CI/CD pipeline an absolute tangled mess.
So you might be asking, why on earth do we put ourselves through all this? Well, it's because the strategic wins you get from a multi-cloud approach are just too good to ignore. You can dodge getting locked into one single vendor. You get to cherry-pick the absolute best tool for the job, maybe Azure for identity, but Google for your heavy-duty data analytics. And it's a fantastic strategy for disaster recovery.
So, the solution isn't to just throw up your hands and retreat back to a single cloud. Nope, it's about building a smart, secure bridge between them. And that bridge is built on a really cool concept called federated identity.
Probably the best way to wrap your head around this is to think of it like a digital passport, or maybe a universal keychain. Your identity gets checked and verified one time by one single source that everyone trusts. And once you have that stamp of approval, it's recognized by all your different cloud providers. It lets you in without you having to prove who you are again and again and again.
And of course, there's a formal name for this whole passport system: Federated Identity Management, or FIM. At its heart, it's all about creating this circle of trust between your main identity provider, the one issuing the passport, and all the different cloud services you need to get into.
Okay, so how does this trust actually get built on a technical level? Well, it all boils down to these standardized languages or protocols that all these systems agree to speak. And the 2 big names you absolutely have to know are SAML and OIDC.
So on one side, you've got SAML. Think of it as the established veteran. It's built on XML, and it's been the reliable workhorse for all those big, traditional, browser-based enterprise apps for years. Then on the other side, you've got OIDC, or OpenID Connect. It's the new contender. It's modern, it's built on JSON, and it was designed from the ground up for the world we live in now, full of mobile apps and APIs.
Now let's really break this table down, because the details here are super important. First, look at SAML 2.0. It handles both authentication, that's proving who you are, and authorization, that's what you're allowed to do. It's a powerhouse for enterprise security, perfect for things like B2B portals. Now look at the other 2. OAuth 2.0 is only for authorization. It's like giving an app permission to get your data without handing over your password. OpenID Connect is actually a really thin layer that sits right on top of OAuth 2.0, and it focuses just on that first part, authentication. That combo makes it super lightweight and perfect for modern apps that just need to quickly verify, yep, this is the right user.
All right, enough theory. Let's see how this all comes together in a real-world architecture. How do you actually take these protocols and build a working system that connects all your clouds?
So, the most common and effective pattern is what's called the identity broker. Take a look at the center of this diagram. See that federated identity broker? It's sitting right in the middle, acting like a central traffic cop for all things identity. All your different cloud providers and apps down at the bottom, they all talk to the broker. But, and this is key, look at the security layers sitting on top of it, like multi-factor authentication and real-time trust assessment. Those layers make sure that before the broker lets anyone in, their identity is double and triple checked right then and there.
But hey, authentication is really only half the story. What happens when a new employee joins the team, or when someone leaves? You have to create or delete their accounts across all of those clouds. Doing that by hand is slow, and it's just asking for mistakes. That's exactly where a standard called SIM comes into play. It automates the whole process of creating and deleting users.
And this is a brilliant concrete example of how it works. Say you want to connect Azure AD to AWS. It's pretty straightforward. First, you just enable SIM over in AWS, and it gives you a special URL and a secret token.
Then you hop over to Azure, find your enterprise app for AWS, and you just plug that URL and token right in. You test the connection, and boom. From that moment on, any user you add to that app in Azure automatically gets an account in AWS. And if you remove them from Azure, their AWS access is gone, instantly. It's a beautiful automation.
So here's the crucial point. The technology exists to make all of this work, which is great. But the architectural choices you make have some serious consequences, especially when you're trying to figure out how to separate your customers' data in a multi-tenant app.
And this is honestly one of the biggest questions an architect has to answer. Do you go all out and give every single customer their own completely separate infrastructure? Their own databases, their own containers, the whole shebang. Or do you put everyone on shared infrastructure, but separate their data logically, maybe with something as simple as a tenant ID column in your database?
Choosing that full isolation path might feel like the safest, most secure option, but let me tell you, it can lead to a world of pain. Just listen to what this developer experienced. That approach can make your costs absolutely skyrocket and turn your deployment pipeline into a nightmare, where a simple update takes days to push out. So, to build a system that's both secure and manageable, you have to stick to the proven best practices. This means you enforce multi-factor authentication, MFA, everywhere, no excuses. It means instead of using permanent secret keys that can get stolen, you use temporary credentials that expire, which massively lowers your risk. And this is critical. You centralize all of your audit logs so you have one single place to see who is doing what across every single one of your clouds.
And all of this brings us to one last big picture question. We've spent this whole time talking about centralizing identity with a broker to handle the complexity of a few clouds. But think about it. As our digital lives get scattered across more and more services, maybe the ultimate answer isn't just a bigger, better central authority. Maybe it's a decentralized model where you, the user, actually hold the keys to your own digital identity. It's a fundamental shift in thinking for sure, and it might just be where we're all headed.